All right, let's go through and solve a triangle. This is going to be the side-side angle case for a triangle. We're going to use the law of sines to do this. So I drew just kind of an ambiguous triangle here, definitely not drawn to scale by any means. And let's work through. This actually works out to be the two triangle case, the ambiguous case. So in getting going on this, we have opposite side and angle. That allows us to use the law of sines. So as we get setting this up, I'm going to try to find C, this angle, first. So I'm going to set this up to be sine of 40 degrees over the opposite side, 120, is going to be sine of angle C over 164. All right, in solving this down, we're going to multiply both sides by 164. These will get to cancel out, so we'll have sine of C on the right-hand side, and we're going to apply a sine inverse to both sides. This is where things get a little bit difficult. So we do the sine inverse on both sides, so that'll be 164 multiplied by sine of 40 degrees on the numerator over 120. As we do the sine inverse, we have to be a little bit careful that this works out to be 61.459. I'm going to round this to 61.5 degrees. All right. At this point, because we applied a sine inverse, we want to be a little bit careful that sine is both positive in the first and second quadrant. So what I'm going to do is I'm going to use that 61.5 as a reference angle in the second quadrant, and then calculate the angle that wraps around into the second quadrant by doing 180 degrees minus 61.5. All right, this works out to be 118.5 degrees. Because 118.5 plus the angle that we already know, the 40 degrees, works out to be 158.5 degrees. That's smaller than 180 degrees. What that means is we can have a second triangle that can be created in this case. So what I'm going to do is I'm going to signify this first triangle using sub ones. And I'm going to create a second triangle using sub twos. All right, where angle C is going to be that 118.5 that we calculated to be into the second quadrant. So 118.5 degrees for a second triangle. So our first triangle, we're going to use 61.5 degrees for C. The one in the first quadrant, the acute angle that was returned to us by using the sine inverse. But whenever you apply a sine inverse, you have to be a little bit careful that you could get a second angle in the second quadrant that could also create a second triangle. All right, so the sub ones are going to be this first triangle using the 61.5. The second triangle we'll do at the bottom there using sub twos. All right, so the next thing that we can calculate in this triangle is we know two of our three angles. We also should know that our angles have to add up to 180 degrees. So our angle A1 can be 180 minus the two angles that we know, the 61.5 and the 40 degrees. So angle A can be calculated in this situation to be 78.5. All right, the only thing that we don't know at this point is side A1. All right, so to get that, what I'm going to do is use the version of law of sines that has our side A1 divided by sine of the angle A, 78.5 degrees equals, and I'm just going to go and use our b's that were given to us initially. So 120 over sine of 40 degrees. A little multiplying both sides by sine of 78.5, and we'll get A1 equals 120 multiplied by sine of 78.5 degrees over sine of 40 degrees. And we'll just put that into our calculator. I got 182.9. All right, so this first triangle has been solved. We found all the sides and all the angles. So let's move on to our second triangle. Again, not drawn to scale by any means. The calculations we'll do here is first, I know two of the three angles. Let's find A2 by saying 180 minus the 2 that we know, 118.5 minus 40. To make sure they all add up to 180, we'll just subtract the other 2 away and get 21.5 degrees. All right, and then the very last thing we need to calculate is A sub 2. Again, I'm going back to law of sines and using A sub 2 over sine of 21.5 degrees equals, I'm going to use the b's again. We could use c's just as easily, but 120 divided by sine of 40 degrees. A little bit of multiplying by that denominator to get the A sub 2 by itself, and we'll get 120 multiplied by sine of 21.5 degrees over sine of 40 degrees. Make sure you're in degree mode in your calculator, and we should be able to get A sub 2 is going to be 68.4. 68.4. And that solves our second triangle. So this is the ambiguous case where we get 2 triangles. Just take your time as you go through it. I think students struggle the most in getting that second value. Basically, this calculation I did over here where we have to place, using the sine inverse, we got the 61.5. We have to calculate what it would be if that's the reference angle for the angle that also produces a positive value for sine in the second quadrant. So take your time as you go through this. Hopefully this helps out as you work on this ambiguous case and find both triangles. All right, good luck on them.